Our essential question in this video is, what are the three rigid transformations? And we learned that last year. Those are called isometries. What are the three rigid transformations which produce congruent images? What are the three rigid transformations or isometries which produce congruent images? This is all going to be a little bit review, but I want to go over it with you. I'm going to show you how we can use transformation notation to describe transformations in a coordinate grid. So let's take a look at the first one. Let's take a look at how we show a translation. A translation. Another word to describe translation is the word slide. We are sliding in a shape in the coordinate grid without turning it or flipping it. And here's our example. Let's do an example. So in this case, we'll do an example. Let's slide this triangle right 6 units and down 2. Let's slide it right 6 units and down 2. Alright, let's do a little bit of labeling here. Actually, let's take a look at the bottom first. To describe this using transformation notation, we're going to take all of our points, our original points, and we're going to take the x value and add 6 to it. That's going to move the coordinate right 6. Then we're going to take our y value and subtract 2 from it. That's going to move our y values down 2, which is what we want to do. Now, before we figured out all of our new points using transformation notation, we're going to label a few things here. Let's label point A, and that's at -3, 5. And then B, looks like that's at -5, 3. And our C value appears to be at -2, 3. So there's our original points. Let's go ahead and use our transformation notation to find the new points. So point A started off at -3, 5. Let's transform that. -3 plus 6 is +3. 5 minus 2 is 3. There's going to be our new coordinate. And by the way, actually, you know what? Let's write that new coordinate in prime notation. A prime is going to be 3, 3. Let's take a look at B. B started off at -5, 3. We're going to translate that to B prime. And B prime is going to be -5 plus 6 is 1. And 3 minus 2 is also 1. And then let's find where C is going to go. C started off at -2, 3. That's going to move to C prime. -2 plus 6 is 4. And 3 minus 2 is 1. So you can see by using the transformation notation, we can find the coordinates of the three new points being translated 6 right and down 2. Alright, let's plot them. So A prime is going to be 3, 3. 1, 2, 3. 1, 2, 3. There's A prime. I'm going to label that. And then B prime is going to be at 1, 1. And then C prime is going to be at 1, 2, 3, 4, 1. And now let's go ahead and connect those sides together. Make this a little thinner. And there's our side 1, side 2. When you sketch the triangle, it doesn't need to be perfect, but you should be trying to be accurate. And there is our translation. Right 6 and down 2, and we used transformation notation to actually get us to our new points. Let's take a look at the next one. What happens if we reflect? Let's go ahead and do a reflection using transformation notation. And reflection, sometimes we can also describe that as a flip. And here's our example. Let me see, here's our triangle. Let's flip across the y-axis. Now our transformation notation to flip across the y-axis is xy becomes negative xy. So let's go ahead and label our original triangle first. Let's call this A, and that's going to be at 3, 4. B looks like it's at 2, 2, and C is at 5, 2. All right, let's use transformation notation for this. So A was originally at 3, 4. We're going to transform that. The x value is going to flip sign. The y value is going to stay the same. And I forgot to write A prime. It's going to become A prime, negative 3, 4. All right, let's try B. B started off as 2, 2. That's going to transform to B prime, which is negative 2, 2. Remember, flip the sign of H, keep the sign of Y for this one. And then C started off at 5, 2. And that's going to now end up being C prime, which is negative 5, 2. Let's go ahead and plot our new points. A is at 1, 2, 3, 1, 2, 3, 4. There's A prime. B prime is negative 2, 2. C prime is at negative 2, 3, 4, 5, 2. And here is our transformed triangle by flipping across the y-axis. You can even see it looks like a mirror. It's like a triangle. The original triangle is in a mirror if the y-axis was the mirror. All right. There is an example of reflection. Last one let's do. Let's use transformation notation to do a rotation. Now this one is where most students have a difficult time. The rest of them, you probably just pause the video and just did it yourself because you knew how to do it. But rotation or turn, this can be very confusing where the shape ends up. So follow the directions of the transformation notation. I will give them to you, so you know how to rotate 90 degree clockwise, counterclockwise, and 180 degrees. So here's our example. Let's turn this pre-image. We're going to turn it 90 degrees clockwise. And remember, when we're turning things in this unit, we're always going to be doing it around the origin. So put this in parentheses in the margin. This is going to be turning around the origin. All right, let's follow our procedure that we did before. We're going to label our original A, B, and C values. So in this case, A appears to be negative 3, 6. Our original B coordinate looks like it's negative 5, 4. And our original C looks like it is negative 2, 4. So there's our original points. Let's apply our transformation notation to that and see where our new coordinates end up. So A started off as negative 3, 6. Now watch what happens to get A prime. In this case, I want you to notice for this particular rotation, the x and the y values flip positions. So y is now in position 1. Well, y was 6, so now position 1 becomes 6, and x here was negative 3. That's moved to the back of our coordinate, and the sign has flipped, so it's 6, positive 3. So notice, when you do rotation a lot of times, the x and the y coordinates flip spaces, and sometimes one of them will change to negative. Now a lot of students get confused and they'll write negative 3 here because there's a negative in this spot. I want you to realize, take the x value, move it to the back of our new coordinate, and flip the sign. Take our y value and move it to the front of our coordinate, and don't change the sign. If you want to pause right now and see if you can do B and C by yourself, that would be a great practice. So I'm going to write B and I'm going to write C. Pause the video, try to find B prime and C prime, and then come back to the video and see if you have it correct. All right, B. If the y value was 4, that now moves to the front and the sign doesn't change. The x value was -5, that moves to the back and we flip the sign. See again, we have our x value, our y value was 4, it now goes to the front of the new coordinate with no sign change, and the x value, which was -2, moves to the back of our new coordinate and that sign flips. So there's our new coordinates. Let's see how they look on the grid. So I've got A prime is 1, 2, 3, 4, 5, 6, 1, 2, 3 right here. Doesn't that seem unusual? Let's take a look at the next one. Now, here's the good part is, once you rotate these three, it better look like it's the same shape, but just turned. So let's take a look at B. B prime is 1, 2, 3, 4, 1, 2, 3, 4, 5. And then C prime is 1, 2, 3, 4, 1, 2. There is C prime. Let's connect those together. And looks to me like it's going to make a congruent triangle that's just rotated. And again, remember, we're rotating around the origin. There is our point of rotation. And that definitely looks like that triangle. If you turn your paper and just look at the two of you, kind of turn it around and see, you'll see that is the same triangle, but now it's been rotated. And I'll put even a note here for you. It's being rotated 90 degrees, and that is a clockwise turn. All right, there's your examples of the 3 rigid transformations on a coordinate grid using transformation notation.